In this video clip, I'm going to talk about how to calculate wave speed for a wave. So I'll draw a wave here and give you some numbers for it. So here's our wave, and I'll say that the wavelength, recall that the wavelength is the distance from a crest to a crest, or a trough to a trough, or a corresponding node to node. I'll say the wavelength, lambda, is 3 meters. So the distance between any crest to crest is 3 meters. And let's see the time it takes for it to go from the crest to crest. The time is 6 seconds. Time is 6 seconds. So we want to find the wave speed. So in the solution, we list the equations. The first equation is, well, for speed, you probably learned that speed is a distance over a time in previous science classes, and it still is, except the distance we're interested in is the wavelength distance, because it's still a distance, and how long it takes to do it. So for our variables, we list all three variables: speed, wavelength, and time. I'm not listing the D here. I was giving an analogy of how you calculate speed for cars versus waves. So for waves, it's speed, wavelength, and time. Speed we're trying to find. The wavelength was 3 meters, and the time was 6 seconds. There's a 6 right there. Not so clear. And so the speed is our wavelength over time, which is our 3 divided by 6 seconds, or 0.5 meters per second. So if this were an ocean wave and it covered 3 meters, which is about 9 feet over a 6-second period, the speed would be about 0.5 meters per second, which is relatively slow. However, that's the speed, and we box our answer, and that's the format for solving a wave speed type problem.